Okay, folks, in the last video we spoke about automatic and effortful processing, and today we're going to kind of continue that. It's the second half of our reading assignment. We're going to talk about what type of effortful processing aids in our retention of knowledge. So a couple of the researchers that we spoke about in our last video were Craik and Tulving. And this was an interesting study because it kind of dealt with how different types of effortful processing affects our ability to encode information. What they did was, with their subjects, they would flash a word on a screen, and when the word disappeared, they would then ask questions that required viewers to process the word at least one level, and that level varied from term to term. And that level of cognition was either visual memory or acoustic or semantic. And we'll talk a little bit about all of those. If they flashed a word and it was followed by a visual clue and the subjects had to answer yes or no questions. So if they, for example, flashed the word chair, and when chair disappeared, they would follow with this question, is the word in capital letters? And the subject would, of course, mark yes, because they can visually see what types of letters those terms are in. So they had to have visually encoded the information. Some of the words were followed by an acoustic cue. So if we flash the word brain, they might ask, does the word rhyme with train? And rhyming, of course, if they would have said yes, they had to have acoustically encoded that word to know what it sounds like, because acoustic encoding deals with how things sound like. And they also, after some of the words, asked a semantically encoded clue. Now, semantic encoding deals with, did we process the meaning of a word or concept? So if they flashed the word gun, and that was followed by a question such as, does the word fit into this sentence? The girl put the blank on the table, and they said yes. That required a different type of encoding. They had to understand the principle, the concept, or the meaning. So the question that Craik and Tulving were looking at was which type of processing better prepared the subjects to recognize the word at a later time, which meant, did they encode the word through the questions. And what they did find out was that the deeper semantic encoding from the third type of question triggered better memory than the other two. And we can see that in the post-test, Craik and Tulving flashed several terms at the same sequence, and reader or subjects had to recognize was one of the words in that list one of the terms they had seen before. And you'll notice that visual encoding terms that they asked, was it in capital letters, was recalled about 10 to 12% of the time accuracy. So not that great. If the word was in a list and they had to have acoustically encoded it, it was almost 60% of the time they picked out the correct term accurately. Get rid of that. But the type of encoding that processed the most accurate retrieval was almost at 90%, was the semantic encoding. So semantic processing, if you process information deeply, which means you have to understand what the term or concept means, produces better retention of information. And as a student, that's going to help if we're studying, what does this mean? How does this relate to other information that I'm learning or my past information? So when you have to question information and you have to understand what terms mean and how they fit together, that's semantic encoding. And that produces deeper processing, as you can see from this chart here. Other methods of effortful processing that assist in retention and encoding is rephrasing or paraphrasing information into meaningful terms. This requires working memory, and we briefly spoke about that this is kind of like your CEO process, your central executive system. And when you have to process information in several different ways besides just what it looks like or sounds like, that effort, the quality of the effortful processing means something. So it's not just saying it, repeating it, it's actually doing some active thinking. That seems to be the best way to encode information. So it's not just the amount remembered depends on the time spent learning, it also means what type of effort did you make to learn the information. So as you study, just reading the information probably is not going to help you as much as reading, stopping, thinking, elaborating, questioning, and connecting to previous experiences. Self-reference effect, the effect of referencing yourself. Anytime you can make information personally meaningful and connect to events that have already happened to you, since you are the most important person in your life, enhances encoding. Imagery also enhances information, effortful processing. What might it look like to you? That enhances our encoding. I wonder how this fits in with me. And also the ability to picture something helps us remember things. So it's probably easier to remember the word computer in a list because we know what that looks like than abstract terms such as the word process or maybe the word justice, for example. It's hard to picture what that looks like, but it's easier to form an image of a computer. You might also guess that two types of encoding are better than one. Anytime we can use acoustic and visual would be better than any of them singularly. There's a few other memory enhancers that we can use as we are studying. One of those is the ability to chunk information, which means if we can group information together. So we're not remembering words separately. And when we learn to read and we become efficient at reading, we're actually grouping letters together to form words and words together to form statements and statements together to form whole concepts. So it's probably a lot easier to remember 7 years ago than it is to remember the same letters but in a different order. And even if we have actual words, trying to remember 7 ago, 4, and years score is going to be much more difficult because we can't chunk for meaning. So anytime we can group information meaningfully together, we will enhance our ability to encode that information. And lastly, we're going to look at hierarchies. And it seems in our memories when we become more knowledgeable in a concept or topic that we tend to form these hierarchies. We group from general to specific. And as we study, if we really remember this general concept, that will help us remember the more specific information below. So broad topics are divided and subdivided into smaller, more precise concepts. So remember we had encoding as a general topic, and then we divided that into auto and effortful, and we divided effortful even further down into things like rehearsal and so forth. So does this really work? Well, Gordon Bauer, the last guy that we pointed out at the beginning of our video yesterday, presented words either randomly or grouped into related information. And we know from chunking that related information was probably recalled better. So later on, we're going to talk about a topic with operant conditioning, which is a general topic, and then that term is divided into more specific examples. And I could even take this into, for example, positive reinforcement and negative reinforcement, and primary and secondary. And each subtopic kind of reminds me of other subtopics. So it allows organized information is just better remembered than random. So if you're just doing note cards and you're trying to memorize words individually without organizing them by topic, for example, you're going to be wasting your time. Well, maybe not totally wasting your time, it is better than nothing. But if you can organize and create hierarchies, how do these words fit with a concept that we know, you'll remember things better. For example, chunking, let's look at those letters. How long would it take us to memorize that list of letters? It's going to take a while, right? But what if we grouped them differently? And from there we can separate them a little bit. Instead of how many different letters we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters. This is only 4 chunks. And we have semantically encoded them because we understand what each of those means. And we have also visually processed and acoustically because we had to talk about them and we heard them. So that's it for encoding. Rewind. I know some of you want me to say be kind and rewind, so I'm going to. And review your notes and look at your Cornell notes if you need to, and make sure you use the guiding questions. And we'll have some practice FRQ questions when we get back. Thanks a lot, and I hope this was helpful.